Okay, so we pick up with here with the notes today. So Taylor, you were gone yesterday, right? And Holly? Oh, all right. Don't remember you. Must not have answered too many questions. Oh, you didn't take tests because you were gone. Got it. Okay, so where am I? Oh, if you were not here yesterday, you maybe won't be able to follow everything we do, but you should be able to get caught up pretty quickly. We didn't cover a whole lot of material yesterday. But before we do this, I just want to kind of give you the reasoning behind what we were doing. I remember that yesterday, you don't have to write this down, but I mean, if you wanted to plot the square root of 2 on the number line, you could. You'd pick out approximately 1.4 and you'd plot it. But if you wanted to plot 1 minus 3i on the number line, you would have no idea what to do. That's why we plotted it on the complex plane. Now, here's another question. Do you know how to do this? Have we taught you how to multiply complex numbers? Yep. But if I gave you this, the 40th power, that would be pretty involved to multiply that out 40 times, wouldn't it? I can teach you how to do that. It'll take you a minute and a half on Monday. Not kidding. Be very, very quick. Second of all, do you know what the square root of -1 is? I. Be careful here. You know what the square root of I is? I times I is -1, so that's not quite right. Yeah. Oh, no. Seems kind of absurd, doesn't it? It does. We'll teach you how to be able to find the square. In fact, on Monday, I can teach you how to find the 5th root of 2 minus 3i if you want. That means what number do you multiply by itself 5 times to get that? Okay? And that's all the further we'll get into complex number systems in trigonometric form. It's just really a nice, easy introduction. Just a basic introduction in case you see it in college. Yes, question, Emily. Okay. Wow. Got it. Got it. We'll just... It's this, isn't it? You just can't get over it. It's the beard. Okay, all right. Okay, so here we go. Here's what we want to do. We want to take trigonometric numbers, and we want to, or I'm sorry, complex numbers, and we want to place them into trigonometric form. That's our goal. What does a plus bi look like when we put it in trigonometric form? The reason why we do that is because some of the operations I just showed you become much easier when we do that. So this one right here, as you notice, we could write that as a coordinate of, say, AB, because this was the real axis, this was the imaginary axis. So we go A units on the real axis, we go B units in the imaginary direction, and we get that point, we draw the segment, there you have it. And what I'm going to do is I'm going to create a triangle here, because if we're going to do trigonometric form always begins with a triangle. What is this length of the triangle right here? A. What's this length of the triangle? B. And we're going to call this is the distance that this point is away from the origin. Remember what we said? Right. This is the absolute value of z, which is the square root of a squared plus b squared. For our purposes today, we are going to give that a new letter. We're going to call it r. R for radius. That's how far you are from the origin. I'm going to put one more piece in here, and that's an angle, theta. What we want to do is we're not going to use it yet. We want to derive a new way to write this a plus bi. Yes? No. Instead of using a and b to write this number, say for example we had 2 plus 3i, what would that look like if we didn't have an a and a b value, but instead if we had an r value and a theta value? Well, watch what happens here. In that triangle, what's the cosine of theta equal to? What's the cosine of theta? A over r. Adjacent over hypotenuse. What is sine equal to? B over r. Now, if we don't want to have a and b written, we want to get rid of this a, then we should solve for a here. How could you solve for a? What do you multiply both sides by? So you get r cosine of theta is equal to a. And b times the sine of theta is equal to, what? Sorry. R times the sine of theta is equal to b. Well, okay, so we have those two things, and so instead of writing a plus bi, instead of an a, I can write r cosine of theta. And instead of b, I can write, and there's an I in there, isn't there? So I'm going to write ri sine of theta. What do they both share in common? They both have an r. I'm going to factor that out, r times the cosine of theta plus I times the sine of theta. And that is what we refer to as trigonometric form of a complex number. So we want to take things that look like a plus bi, and we want to write them as r cosine of theta plus I sine of theta. And again, it may not look like that's very helpful, but it will be very, very helpful to us, especially on Monday as we start to do more challenging things. Yep. I guess you could think of it that way. It's one way to think of it, but a lot of times our number systems, you know, when you're using the z-axis, a lot of times that's in a real number setting, and that's not the case if you're using the imaginary axis. So there are times where we could consider it that way, but not always. Okay. Oh, so there's really two important parts here. In order to write it, you have to know what r is, and you guys told me r is the square root of what? A squared plus b squared, because it's the same thing as the absolute value of z. Second of all, we have to find theta, and we know this. Tangent of theta is equal to b divided by a, and we can use those two pieces in order to find the necessary parts. So what I want to do now is we've laid the groundwork. I now want to actually put these three examples, these complex numbers, into trigonometric form. Forgot an I there, you can put that on the end. And so here's what we do. We have A and we have B. So R is equal to, what is A squared? b squared? You don't square the I, you just square 2. So you've got 4 plus 4. We don't do anything with the I. B is the number in front of the I. So we get square root of 8, which is 2 roots of 2. Right? Then we set up this. Tangent of theta is equal to, what's B divided by A? 1. In which quadrants is tangent positive? First and third. If we inverse tangent of 1, do you know what angle you get? 45 degrees. But it's equal to 45 degrees in the first quadrant and 225 degrees in the third quadrant. Do you know which one are we talking about? 45 or 225? Which quadrant is your point located in? The first quadrant, over 2 and up 2. So we're talking about 45 degrees. We do not write it in degrees, we write it in radians. So 45 degrees is the same as pi over 4. We're now ready to write the number in trigonometric form. Remember, trigonometric form is this. R cosine of theta plus I sine of theta. So we have R, 2 roots of 2, times cosine of pi over 4 plus I sine of pi over 4. And that's it. Again, I know that that doesn't look prettier than how it started, but we can make great use of that. Yes. So if we inverse tangent equal to 1, we know that that's in the first and the third quadrants. And we know you get 45 degrees. So therefore our angle is going to be either 45 degrees or it's going to be 225 degrees. How do you know which one? Well, if you were to plot 2 plus 2i, you would go over 2 and up 2. So it would be in the first quadrant. So therefore we know it's 45. Then we convert it to radians. The R value is 2 roots of 2, so I take this piece right here. This is my form. So 2 roots of 2, and then I just plug in pi over 4 for theta. Better? Okay. All right, we do the next one. What's your A value? B value? 3 roots of 3. So I have R equals the square root of A squared is 9. B squared, be 3 times 3 is 9. What's the root of 3 times the root of 3? 3. So 3 times 9 is 27. So if you were to square 3 roots of 3, you get 27. 9 plus 27, and square root 6. So I found my R. Now I just have to find theta. I use it by setting up tangent. Tangent of theta is equal to B over A. What's B? Yes. So 3 roots of 3 divided by negative 3, I would get negative root of 3. Tangent is negative in the second quadrant and the fourth quadrant. Am I talking about the second quadrant here or the fourth quadrant? Second quadrant, because you're back 3 and up 3 roots of 3. So therefore, second quadrant. Where is tangent equal to negative root of 3? At 120. Which is also 2 pi over 3. Question. Look on your chart and convert back and forth. So, yep, and if you get the 120 degrees, you can always go times pi over 180. And 120 over 180 reduces to 2/3, and you have your pi. So you got to go back to your conversion then, or at the very least look at your chart. Okay. So I have theta, I have r, so my trigonometric form is 6 times the cosine of 2 pi over 3 plus I sine of 2 pi over 3. That's it. That's trigonometric form of a complex number. It looks really complicated, doesn't it? But really, it just involves tangent and a squared plus b squared. So, not too bad. All right, we do the last one together. And then we're going to do this example, and that's it for the day. Negative 2i. So I have a 0 in front of there. So it's like 0 minus 2i. So what's my a value? And b is negative 2. So r is equal to the square root of, what's a squared? 0 plus b squared? 4. So square root of 4 is 2. So my r value is 2. Then I set up the tangent of theta is equal to b divided by a. What's b over a? Undefined. Anything divided by 0 will be undefined. Where is tangent undefined? (90) and 270. Which am I talking about if I'm talking about 0 minus 2i? Is that 90 or 270? 270 because you're going 0 and then down 2, not up 2. Up 2 would be at 90, down 2 would be at 270. 270 in radians is 3 pi over 2. So we have r is 2, theta is 3 pi over 2. Our trigonometric form is 2 times sine of, well, I'm sorry, cosine. Got mixed up. Can I show you the shorter way of doing that problem? Watch the shorter way of doing that problem. I'm going to plot the point 0 and then negative 2i. So I'm located right here. R refers to how far it is from the origin, right? How far is that? 2. What's my angle? So you realize that you could kind of just look at the graph in order to find that information. Not all the time, but in that situation, you sure could, couldn't you? So, very nice. Yo! Yep. That'll be correct. That'll be correct. Okay. Now what we're going to do is we're going to take these trigonometric forms of complex numbers and we're going to multiply them together. So this is going to be a lot of writing down right here, but the problems are really easy. If you can follow what we write down, it's really going to help you for Monday. Otherwise, Monday you'll be very confused. Z1 equals R sub 1 times sine cosine of theta sub 1 plus I sine of theta sub 1. And Z sub 2 is equal to R sub 2 times the cosine of theta sub 2 plus I sine of theta sub 2. And what we want to do is we want to learn to multiply and divide those. So given Z1 is that and Z2 is that, the question is, what is Z1 times Z2? And here's what you do. You take these two R values out front, R1 and R2, you multiply them. You take the angles and you add them. So if you're going to multiply two trigonometric form complex numbers together, multiply the radiuses together, add the angles together. So what do you think you do if you divide? What do you do with the R value? Whoop. Off my game. R1 divided by R2 times cosine of theta 1, very good, minus theta 2 plus I sine theta 1 minus theta 2. There you have it. Looks like a bunch of gibberish, doesn't it? But really, it's quite nice. Watch how quickly we can do this problem. It says Z1 is equal to that, and Z2 is equal to that. It wants to find Z1 times Z2, and Z1 divided by Z2. Well, if I want to multiply them, what do I do to these R values out front? Times them. What's 2 times 5? 10. What do I do to the angles? Add them. Pi over 4 plus pi over 3. Let's leave it in radians. Got to find common denominators, right? Pi over 4 would be 3 pi over 12. And pi over 3 would be 4 pi over 12. Add it and you get 7 pi over 12. Done. That's it. Let's divide them. That's it. That's the answer. Let's say we divide them. What do we do with the R values? So 2/5 times cosine of, what's 3 pi over 12 minus 4 pi over 12? Negative pi over 12. Do we leave the negatives? No. What happens to cosine of a negative? Just becomes positive. What becomes of sine of a negative? Switch it out front, right? Isn't that cool? That's it. That's all I want you to learn today. Can you put numbers in a trigonometric form, and can you then multiply and divide them? That's it. The assignment yesterday was 589, 1 through 8. Today is 7.6, 590. These are 6 problems putting complex form into trigonometric form, and then 2 problems that involve multiplication and division. Your book will say something about, make sure the argument of theta is between 0 and 2 pi. That just means that theta sits between 0 and 2 pi, okay? Don't worry about this word argument, okay? It's a term that is used as we work with these complex number systems. You'll never see it again for this until you get to college. So just do what we did today, you'll be fine. Any questions? Should we give a shout out to anybody? Is there anybody who's going to watch this, do you think? Sid? She was here first hour. Yeah. Caitlin. Oh, hi, Caitlin. Did you want to say something to Caitlin? Do you want to say something to Kate? Do I call her Kate? Uh-oh, she's mad at me now. Do I have to apologize? Oh, goodness. All right. Kate, we hope you have a good one. Addie's here. She won't watch video. Later. We'll stop right at 25 minutes and stop.